Hello students, welcome to your first online class with me in your 6th semester. I'll be discussing the paper 603 which constitutes of nuclear physics, and this is my first lecture. So as in the previous online classes, all my classes will be divided into 2 or 3 lecture videos, each of duration 15 minutes. So students, first let us take a look at the syllabus. So this is your paper 603 nuclear physics, and it is divided into a number of units. Unit 1 15 marks, properties of the atomic nuclei. Unit 2 10 marks, nuclear models. Unit 3 22 marks, it's the biggest unit, nuclear reactions and cosmic rays. Unit 4 13 marks, elementary particles. So first we'll start with the first unit, properties of atomic nuclei, which consists of introduction, nuclear size and its determination, hypothesis of nuclear composition, mass of nucleus and atoms. Now this will be followed by quantum numbers of individual nucleons, quantum properties of nuclear states, nuclear angular momentum, nuclear magnetic dipole moment, binding energy of nucleus, mass defect, packing fraction, disintegration energy, and the semi-empirical mass formula. Actually, these are certain topics, and fortunately, most of the topics in your syllabus, you require only the qualitative description and not the quantitative. So at times it might seem a little boring to you since we don't have much mathematical derivations, but still we'll try to make our teaching learning process interesting. So we start with the introduction. So while dealing with the introduction, let's do a short recap of what we already know about the nucleus, and side by side we'll also be dealing with topics that are required here. So let's go down memory lane. Let's start with the atom. Students, we know the Thomson's atomic model. By the way, what is the atomic model? Atomic model is just a sketch of something. A model is a sketch of something that we actually don't know, but we just assume it to be. So since the atom itself is a very small entity, earlier scientists, they imagined the atom to have certain type of qualities and certain shape and size, and these points and this mental picture they obtained by looking at the observations that were possible at those times. So the Thomson's atomic model was a sketch of the atom which was like this. It is also called the plum pudding model. Here we have the positively charged, a whole positively charged C where small negative charges are embedded. They are distributed evenly, and these at the time we did not know they were the electrons, but we say the negative charges were embedded in the positively charged matter, and that was the Thomson's atomic model. But then, after the Rutherford's alpha particle scattering experiment, which you must be quite familiar with, we came to know that if we had this type, the first picture on the left hand side, that is the Thomson model, if that would have been the size and the shape of an atom, then alpha particles would have moved in straight lines as shown by the straight arrows starting from the left and going towards the right. But Rutherford experiments did not give this result. It was seen that some of the particles got turned away by quite a big angle, as shown in this picture on the right hand side, and it clearly indicated that the atom is not what Thomson had said, but it is like this, with the whole positive charge concentrated at the middle, with the electrons or the negative charges surrounding it. So that gave rise to the idea of a nucleus. So the result of the Rutherford's experiment first pointed out that yes, all the positive charges are concentrated at the center, which was later known to be known as the nucleus. So that we can say this as the birth of a nucleus, because earlier no one thought that there's something called a nucleus. We only had the atom. And after this birth of the nucleus, we have the Rutherford atomic model, where it was thought that the nucleus contained positively charged protons and we had electrons surrounding this nucleus, positively charged nucleus. So that was the Rutherford atomic model, as we all know. Now this then came the difficulty. At the time, due to the electromagnetic theory, we came to the conclusion that accelerated charge particle radiates energy, and since these electrons, they are moving in a circular path, and a circular path is nothing but an accelerated motion. Any particle or body moving in a circular path is having a constant acceleration, so it's accelerated charge, and so it will radiate energy. So let's see what was the consequence of this. The consequence was that if it radiates energy, this electron slowly loses its energy. It moves in a circular path of smaller and smaller radius, and ultimately it meets the positively charged nucleus, and then negatively charged would fall into the nucleus. But this doesn't happen, because if this would have happened, we would have had no atom, no matter, nothing. So obviously what Rutherford, the model that Rutherford proposed, was not true. And after that came the Bohr's model of the atom. And what is the Bohr's model of the atom? We all know it. Here it looks the same as the Rutherford model. The electrons of course moves around the nucleus, but here we have the idea of stationary orbits. But then now we'll not go to the Bohr's model of the atom. What we'll look at now is that in the Bohr's model of the atom, you see so many things happened around in these shells. Electron used to jump from a higher orbit to a lower orbit and then would emit energy and all these things. And if an electron jumped from a lower to the higher energy, then electron energy was absorbed. You see, these things are always going on. The the negatively charged electrons seem to do all that is to be done in an atom. So whatever happened, chemical reactions and all of this took place only due to the motion of the electrons. We had X-ray. What is X-ray? X-ray is a radiation which is different from the normal radiation that comes out, because you see, when a electron in a higher orbit jumps suddenly to a lower orbit, so it loses energy, and then we have X-ray, and these things were well known at the time. But till then we knew nothing about the nucleus, and we never thought about the nucleus. No one thought about the nucleus except that it is a positively charged body with a charge Ze on it if Z is the atomic number. That means if we have Z number of electrons, then we have a positively charged nucleus with Z number of Ze charge, and it had kind of a very passive role, and the only role was to balance the Z into minus E negative charge, which which summed up as a result of the Z electrons surrounding this nucleus. So this nucleus just balanced this positive charge with the negative charge of the electrons. So there was this force of Coulomb attraction due to which the electrons moved around it, and that is atomic physics. Now, around the time radioactivity was discovered. And what is radioactivity? Radioactivity is just spontaneous rays coming out from certain material. And suppose this square object is a material which is a radioactive material. What happens is that it emits radiation, and this radiation constitute of alpha, beta and gamma, and as the text below says, radioactive nucleus does not emit alpha and beta radiations simultaneously. Some nucleus emit alpha particles, others beta particles, and then changes into new nucleus, and to balance the energy, gamma radiations are emitted. So to sum up, I can say that some materials spontaneously by itself it emits certain radiations, and this particular phenomena is said to be radioactivity. Now, what about this radioactivity? The main thing about radioactivity is that it was found that at the time when radioactivity was studied, it was found that any physical or chemical change does not alter the rate of change of radioactivity. That means nothing could change the rate of radioactivity. Now when I talk about X-ray, X-ray is also a kind of radiation, but the difference between X-ray and radioactivity is that in X-ray the intensity and the rate can be changed by applying different voltage or changing certain parameters. But in case of radioactivity, nothing could change the rate, which implied that radioactive rays originated inside the nucleus. Because if it would have happened in the outer electrons, then you see, look at this one. When I talk about the outer electrons, I mean this one. See, these things can be changed. When you supply energy from outside, then electron in a certain orbit will absorb that energy. It may jump down, it may rise up, or if by some method this energy is absorbed, then it may jump up to lower its energy, it may collide, and then it may go to a lower orbit. So this way these things can be the motion of these electrons can be controlled, can be changed by applying energy from other source to the atom. But then it was found that on doing these, the energy and the radiation emitted by a radioactive source could not be controlled. And what that indicated, that means that radioactivity or the ray that comes out due to radioactivity comes out from the nucleus and not from the electrons in the outer orbits. So students, the conclusion was arrived at that radioactive rays originate in the nucleus. So I think I'll stop here.